Math 3, Unit 1, Section 5. Today we're talking about domain restrictions. So remember that the domain represents the x values of a function. Okay? Sometimes functions have the domain restricted to be a subset of their original domain. So what they're saying is they're just asking for one piece of the graph. Okay? When this is the case, the function should only be graphed based on the domain restriction. Sketch the restricted functions and state the domain and range in interval notation of the restricted functions. So the first thing that I like to look at when I'm doing these problems is that right now they are telling me to graph f of x if x is greater than or equal to 0. So the restriction is at 0 and we are only graphing values that are greater than 0. And so I suggest always going to where that restriction is and highlighting that so it reminds you that something's going on there. The graph is stopping, okay? And in this case, because it's greater than 0, then my graph is only going to be going to the right. So far, so good? Yeah? Okay. So now it says f of x equals negative 2x plus 3. What kind of function is this? What kind of graph will this make? Linear, very good. It's going to make a line. And so what would be my starting point for this graph? 0, 3. Is everybody okay with that? Because with the x, there's no parentheses here, so it's 0. And then the y value is the 3. Do you have questions? Okay, 0, 3. So on the x, you see how I'm on the highlighted line right now when I'm going to go graph it? You have to check at 0, is it equal to or not equal to? Will it be an open circle or a closed circle? Closed because of the equal sign. So 0 up 1, 2, 3, and we're going to do a closed circle. Okay, because this is linear, we can choose to either use our slope, focus. We can use our slope or you can plug in a point. Okay? How many of you would prefer to just plug in a point because you have to do that half the time anyways? Okay, how many of you would prefer just to use the slope? Okay, so majority of you prefer to use the slope. So what is my slope here? Good, it is negative 2 over 1. And I can use the slope because why? It's linear, it's a line, but whenever it's a curve, we can't use the slope. Okay, so from here we go down 2 and right 1. And my graph is supposed to be in this area, so I'm good. You could keep going down 2 and right 1 if you want to. But when we draw our line, we are only drawing it in one direction because the restriction is that x has to be greater than or equal to 0. Bless you. Do we have any questions on this first one? Okay, so we're going to go to the next one. On this one, where is my restriction? 4. So we are going to go to the graph real quick, and at 4 we're going to go right 1, 2, 3, 4, x equals 4, and it's saying less than 4. So on this one we are only going to graph stuff to the left there, because those are the values that are less than 4. Okay, what type of graph is this going to be? Very good, it is going to be quadratic. I always write what it is because as I'm graphing it, I want to make sure that I'm graphing the right thing. Because sometimes we'll like make a line, but it's really supposed to be something else. Okay, so with quadratics, you have a vertex. And what is my vertex for this problem? 3, negative 4. Okay, so we go right 1, 2, 3, and then negative 4. 1, 2, 3, 4. And that is not on the line, so we can go ahead and do a solid point there. And then we need to find out, well, what's happening when it's at the restricted value. Also, when you put this this point, sometimes you might want to put a V there to remind you that's a vertex, and so that you know it's symmetrical across that point. Okay, so we're going to plug in 4 into this equation to see what's happening there. So we have 4 minus 3 squared minus 4. 4 minus 3 is what? 1, and 1 squared is what? 1, and 1 minus 4 equals negative 3. So this other point, the x value was 4, and then it became negative 3. So at 4, we go down 1, 2, 3, and will I make an open or a closed circle there? Open. And why is it open? It's just less than, it's not less than or equal to. Now remember, it is symmetrical, so since this is 1 away from our vertex line, we go 1 away on the other side, make that point. And then quadratics are curved, but we're starting here and it just curves like this. So normally it'd curve up that way as well, but because of the restriction, it's not. Do we have questions? Okay, are you guys ready for the next one? So on this one, it's a little bit different because the restriction is from negative 4 to negative 1. So this means, yes? Yes, thank you. So let's go back and do the domain and range. So first of all, on this one, what is my domain? Bracket or parenthesis? Bracket. Why bracket? It's closed. It does equal 0. So if it equals it, it's a bracket. So it's bracket 0 all the way to positive infinity. And then my range, and again, if you want to use your index cards, what is my smallest range value? Good, negative infinity. Now, will I use a bracket or a parenthesis? Parenthesis, because infinity goes on forever. So there isn't an exact value when you're doing negative infinity. It's going on forever, so it never stops. So therefore, it's a parenthesis. And then it goes all the way up to what value on the range? 3. And will that be a bracket or a parenthesis? Bracket, because does it actually equal 3 for the range? Yes. Okay, on this quadratic function, we're going through the left. The domain, what is the smallest domain value? Negative infinity. And going along the x for the domain, what is the biggest domain value? 4. And would that be a parenthesis or a bracket? And again, why is this one a parenthesis? Good, it doesn't actually equal that value. Okay, the range on this one, what is my smallest range value? Parenthesis or bracket? Bracket at negative 4. And then as you go up, even though there's an open circle here, is there a closed part over here? So we're good. We just pass that up and we keep going and we have an arrow up. So that means it's going to positive infinity. Okay. Any questions there? All right, thank you for that. Okay, next one now. So this is saying negative 4 is less than or equal to x is less than is less than negative 1. So we have to now highlight 2 different numbers. We are going to highlight at negative 4. And we are also going to highlight at negative 1. And the graph is only in this area. It's only the values between negative 4 and negative 1. That's what this means. Only from negative 4 to negative 1. What type of function is this? Very good. It is a quadratic. Okay, and what would be my vertex for this quadratic? Good, negative 3, 0 is correct. So let's see if that's in the area that we're graphing. So negative 3, 0, we're going to go left 1, 2, 3, and then up 0. So that is inside the area, correct? So we can go ahead and put that point there. Okay, now we're going to plug in each of these values to see what's happening at the points where we have our restrictions. So we're going to first plug in -4 into this equation. So we have -4 plus 3 squared. What is -4 plus 3? -1, and -1 squared is 1. So this ordered pair, I'm just going to write it as -4, 1. So at -4 up 1, will that be an open or a closed circle? Closed. So do you see here at -4 how it has that equal to sign there? So when I plugged in the x value for -4 equaled 1, and so at -4, 1, it's a closed circle. Now we do know this is symmetrical across this vertex here, right? So you could put another point here because we know that it's going to curve like that, but we also need to know what's happening here at this value. So next we're going to plug in -1. So we're plugging -1 into this equation. -1 plus 3 squared. -1 plus 3 is 2, and then 2 squared is 4. So this is -1, 4. At -1, will it be an open or a closed circle? Open. So I'm going to write open here. We'll write closed here just to remind you how I'm doing it. So we go -1 up 1, 2, 3, 4, and this is an open circle. And then we can draw our curve, staying within those restrictions. Do you want to ask me any questions? Okay, so now we need to state the domain and range. What is my domain? What is the smallest x value? Parenthesis or bracket? Bracket. And it's a bracket because it's a closed dot. It's equal to -4. And then going up, the largest x value is at -1, right? This is at -1. And is it a parenthesis or a bracket? Parenthesis. And we know it's a parenthesis because open circle and open circles mean not equal, right? Okay, range. What is my smallest range value? 0. Bracket or parenthesis? Bracket. And then my largest range value is up here, which is at what? 4. And would that be a parenthesis or a bracket? Parenthesis because it's a open circle. Do we have any questions? Okay, do you think you guys are ready to try one on your own? Yeah? Okay. Let's see what you can do. If you have questions, I'm going to be walking around. Okay, does somebody think they have it right and they're ready? They might want to come up and do it. Okay, no volunteers right now? Okay, all right, let's talk through this. I can see some of you. Okay, so just real quick, this is what it should look like if you want to see if you kind of got it right. Okay, right here. All right, now we're going to go through it. How many of you got it right? Nice. Okay. All right. So my restrictions, where I need to highlight, is where? Good. -3 and 5. So we're going to go -1, 2, 3. And then 5. 1, 2, 3, 4, 5. And we're just highlighting so we're very focused that my graph is in between here. So the graph is going from here to here. There's not going to be anything on these other sides. Now, what type of graph is this? Very good. Absolute value. And specifically like a linear absolute value, correct? Okay, what is my vertex for this problem? 0, 4. 0 with the x, and then 4 for my y. Everybody's good? So 0 up 1, 2, 3, 4. It's not on a highlighted line, so I can just make my point. Okay? Now, could I use my slope on here if I wanted to? Yes. And what is my slope? My slope is -1 over 1. So from here, you could go -1, right 1, and then know it's symmetrical and do the 1 on the other side. And you could keep going all the way till you hit the points on your highlighted graphs. Does that make sense? Or we can plug in our values. For this case, I'm going to go ahead and plug in the values. We're going to plug in -3 because I need to know what's happening on that line at -3. So we have negative absolute value of -3 plus 4. What is the absolute value of -3? Sorry about that. 3. So now I have -3 plus 4, which equals what? 1. Cole, are you getting this with us? Okay, so -3, 1. So -3 up 1. Now, at -3, is it going to be open or closed? Open. If you are forgetting to do like open and closed, when you highlight that, look, and then maybe make a note here. It's supposed to be open. And at 5 here, if I look at this information, at 5 it should be closed. And we know that because of the equal sign here and not having an equal sign there. So if you forget, I would just label your graphs that way. So now I'm going to plug in 5 into here to see what's happening at 5. So we have negative absolute value of 5 plus 4. What's the absolute value of 5? 5. So we have -5 plus 4 because the negative outside stays there. And -5 plus 4 makes -1. So this is 5, -1. And we already know it's closed. And so now we can draw our lines. And we're done there. Do you want to ask me any questions? Okay, so domain and range. Domain is what? Parenthesis, -3, all the way to 5, and then it will be a bracket. The range, smallest range value is at what? -1, and that's going to be a bracket. So using our card, that's -1 on the y, and we go up. We have an open circle, but because there's a line over here, we're good. We can just pass that up and keep going. And then the highest range value is at what? 4, and is that a parenthesis or a bracket? Bracket. Any questions before moving on? Okay. Now, this one is a little bit different because on this one, they're saying graph f of x if x doesn't equal 1. So all that means is it's going to be everything on the graph, but at 1, whenever it hits 1, that would make an open circle because it can't equal that value. So I'm just going to write here, open at 1. But everything else in the graph we would do. What type of graph is this going to make? Very good. Exponential is correct. We know it's exponential because there is an x in the exponent. Very good. Okay, our starting point for exponential functions is always at what? 0, 1. So we always mark an x at 0, 1 because it's not, we don't know if that's actually going to be a point yet. And then how is this one going to translate? Very good. This one is going to translate down 5. There is nothing up there with the x. And then this number at the end tells you the up and down translation, and it's going down 5. So 0, 1, it's going to go down 1, 2, 3, 4, 5, and we make our point. What about our asymptote? Where is that going to be? -5. So it's always at 0, and then if you translate up or down at all, that's how your asymptote also translates.
Why would they put down 5 and not 1 for the sides?
So with the x value, that's when you are going right and left. And since there's nothing up there with the x, it's not translating or shifting right or left. And this, the -5 at the end, is dealing with the shift in the y.
So if you plug in 5 right now,
If you plug in 0 right now, you would get an answer of -5. Wait, no, you get -4, sorry. Because you're starting at 0, 1, right? And so if you plug in 0, 3 to the 0 is 1, and 1 minus 5 equals -4. And so if you notice, this is 0, and then 1, 2, 3, 0, -4. And remember, this one is the only one that doesn't start like at 0, 0, because anything to the 0 power will always equal 1. And so therefore, the starting point is 0, 1 and not 0, 0 because it's an exponential function. Okay, are we all okay with that asymptote there too? Yeah? Okay, and then we always want to choose one value to the right of wherever our starting was. And that works out nice here because we want to actually see what it equals on 1 to the right of that. So we're going to plug 1 into this equation now. 3 to the first power minus 5. What is 3 to the first power? 3. And then 3 minus 5 equals -2. So at 1, it's 1, -2. So 1, -2. And what am I going to do here? Open circle. And can I make it past that open circle? Yes, because on this one, it's just an open circle at that value, right? And everything else can be graphed. So this is going to keep going up this way, and this is going to keep going down and get close to that asymptote. And it's just an open circle at that one point. How will we write our domain for this one?
open circle, 1.
Good, -infinity to 1. And then are we going to make a parenthesis or a bracket? Parenthesis. So that's taking care of -infinity all the way to there where you have that open circle. But then it keeps going, right? And so do you remember how we write that? Good. U, parenthesis, 1 to positive infinity. Very good. Do we remember that? Okay. Now, for our range, what is the smallest range value? Good. -5 is correct. Is that a parenthesis or a bracket? It's actually -5. Sorry. So remember that it's at your asymptote is where your smallest value is. It doesn't ever equal that, but that's the one that it gets really close to. And so the asymptote value is really the value for exponential functions where your range is starting. So in this case, it's at -5, but we use a parenthesis because it doesn't actually touch that asymptote. So -5, and then as you go up, there's an open circle here. Do we have to stop there? Do you see like a filled in line anywhere else on the graph? No. So we do. We have to stop there. So what is that value there on for the range? Good. So -5 to -2, parenthesis. And then it starts back up again, right? So we do the union and then -2, and it goes all the way to positive infinity. Are we confused about anything there? All right. Are we ready for the next one then? Okay. So what does this one say? Okay, so this says f of x equals 2. Just so you know, that's the same thing as just saying y equals -2. Okay? But when we look at our restriction here, this says graph f of x if x equals 3. So what does that mean? Yeah, you can only give information at 3. So remember at this one, it was an open circle at 1. This one is, you can only have a point on that highlighted line. That's it. So if you plug 3 into this equation, is there an x anywhere to plug a 3 in? No. And so that means that this equation is actually, or this point is at 3, -2. So 3, -2, it can only equal that point, and that is it. If you were to draw this line y equals -2, just so you know, that would be a line going, I'm just going to highlight this in a different color because this isn't actually part of the graph, but this would be your line right here. Okay, that is this. But because they're saying that it's only where x equals 3, you can only plot the point at x equals 3, there's only one actual point you're plotting because it can only equal there. Does that make more sense? Awesome. Okay, so what's your domain on this? So what x value does this equal? 3. So it's just a bracket at 3. It only equals that one value. Range, what is my range? -2. In brackets, it only equals that value. Okay, do you want to ask me any questions before we move on? So remember this pink line right here was just to show you what this graph looked like, but it's not actually the only thing that is really on my graph is that one point. Okay, are we good? It's not time to leave. Don't get excited. Okay. All right. Write the function and its restricted domain for the given graphs. So here, they've given you the graph, and we need to basically write the function and write the restrictions. Again, I like to highlight where it's starting and stopping, so it's easier for me to kind of see what's going on. So I'm going to highlight this how I normally would have highlighted when I was making the graph, okay? So looking at this, do you guys, I think it's easiest to start by writing like your restriction. So do you see how it's starting and stopping and it's not going to infinity? Do you guys remember how we would write that? You're going to use inequality notation. So the smallest value is where? -4. So that's where we go. -4 is what? Less than or equal to. How'd you know it was equal to? Yeah, it's a closed dot. There's no open circle, right? So less than or equal to x is less than or equal to 1. So it's saying all the values between -4 and 1. Everyone okay with that? Yeah? All right. What type of function is this? Quadratic. And we know that our quadratic functions look like this. Y equals a x plus something squared plus something. Right? Do you guys agree? So these two values come from our vertex. Do you see the vertex on here? What is that vertex? -1, 4. How do I put this into this equation right here? How will I rewrite that? So a parentheses and it'll be x what? X plus 1 squared and then what? Plus 4. And why is it plus 1? Yeah, because when it comes out, it has to be the opposite, right? Remember the stuff in the parentheses? We set equal to 0 and it becomes the opposite value. So in order to make this equal to -1 when it comes out, it has to be plus 1 when it's in the parentheses. Okay, how do I find what the a value is? Plug in a point. Does it matter what point I plug in? No, I would just want to make sure that I pick a point that is like an actual point on a graph. So, like, what about this point? Can I plug in this point? Yeah. Can I plug in the vertex? No, you cannot plug in the vertex. So anything except for that vertex. So anything except for like your starting point. So what is that point right there? 1, 0. That's x and y. I always label those so that I actually put them in for x and y here. We're substituting in. So my y is 0 equals a. My x is 1 and then plus 1 squared plus 4. I heard a what? So we are at this pink. We wrote this with our vertex, correct? Then we choose another point on the graph that's not the vertex. I just chose 1, 0. You could have chose this point. You probably could have chosen this point. You just want to make sure it's an exact point. And then we plug these values in to solve for a. So I'm plugging in 1 for x and 0 for y. And then we're simplifying. What is 1 plus 1? 2. Okay? And then what is 2 squared? 4. So I have 0 equals 4a plus 4. And what do I do to solve that? Subtract 4 to both sides. This eliminates. We have -4 equals 4a. We divide by 4. And what does a equal? -1. Good. So -1 goes in for my a value. So my equation is y equals -1 x plus 1 squared plus 4, or it could just be a negative in front. But you need to write it back up here. So it says f of x equals, and what will I write? Negative parenthesis x plus 1 squared plus 4. So it's like we're putting everything that we've learned together in one. Yes?
Can you put -1 in the parentheses?
Yeah, so you can totally put a -1 there, like that. Okay. Do we want to revisit anything on this problem? We're okay? Do you guys need to look at anything? Are you guys ready to move on? Okay, I'm going to put it up. Can we see that better? Do we have questions? Juan, do you want to ask me something or not right now? Okay. All right, last question. Here we go. Let's see what we can do. So, first of all, this is infinity, or negative infinity, correct? And then this is our restriction is right here. So, it's everything to the left of that point. What do you think would be, how would I write that? Close. What is, the x value is at what? 2. So it would be x is less than or equal to 2. Are we good with that? Okay, what type of function is this? Absolute value. So absolute value is where we have y equals a absolute value of x plus something plus something, correct? So we plug in our vertex here. What is my vertex? 1, -3. So how will I write this function with that point in? So y equals a absolute value of what? X minus 1, because we want to make it a positive 1 for the vertex, and then on the outside it's going to be what? -3. Okay, questions up to this point? What do I still need to find? Good, that a value, correct? Can I plug in my vertex? No, we had to plug in another point. Could I plug the point that's right here? Yeah, what is that point? 2, -2, and I'm going to label it with x and y, and we take those values and we plug them in here to solve for a. So when I write this, we're going to write it as what? -2, a absolute value of 2 minus 1 minus 3. Okay, what is 2 minus 1? 2 minus 1 is 1, and what's the absolute value of 1? 1. So -2 equals 1a minus 3. What would I do next to solve this? Add 3 to both sides, and what's -2 plus 3? 1. So 1 equals 1a, or 1 equals a. So that is the value to plug in for a. Y equals, you can write the 1 if you want to, or you don't have to write the 1, absolute value x minus 1 minus 3. If you want to put the 1 in front here, you can. You just don't have to have it. Okay? And then same thing, we just have to write that back up on this line. So f of x equals the absolute value of x minus 1 minus 3. Do we have any questions?